Hi students, welcome back. So in the previous video I explained about the syntax directed translation. What is SDT? So SDT is nothing but it is a combination of a grammar plus semantic rule. Grammar plus semantic rule, you call it as an SDT. So what are the different schemes for this syntax directed translation? In syntax directed translation schema is a context free grammar. So it's just SDT schema is a context free grammar. We know that, okay, whatever the productions you are taking that, so that is a context free grammar. It is used to evaluate the order of semantic rules. The main use of the syntax directed translation schema is to evaluate the order of semantic rules. So just or the rules, whatever the rules that are there for semantic rules. So it just evaluate the order of those semantic rules. In translation schema, the semantic rules are embedded with the right side of the production. So just it is embedded with the right side of the productions. The position at which an action is to be executed is shown by enclosed between the braces. So whatever the action that has to be executed, that should be enclosed between the braces. It is written within the right side of the production. So just write the right side of the production, like E determines, like right side of the productions. Okay, so let's see the example for this syntax directed translation. So whatever I explained that SDT, so just like that, but the syntax directed translation schema is you are going to add one argument grammar. So you already know that the argument grammar. So the production S determines E dollar. Okay, so whenever this production is there, it's nothing but it is going to print the E dot value. So whatever the value that you will get, that value is going to be printed. It's a numeric value. Okay, number, that value is printing, whether it is a number or a string or a memory location, whatever it may be. Okay, so S determines E dollar, it's the first production, and the second production is just same like SDT. So E dot value is equal to E dot value plus E dot value. So these are the actions for these productions. So these are the actions. So that's why we are placed within the braces. Whenever they are placed, the equation, the production is placed within the braces. This represents the action for that production. Just remember, whenever you place the productions along with the attributes, okay, if it is present within the braces, then it represents the action for this production. So action for this production. So for each production, this is an action. So E dot value is equal to E dot value into E dot value. So this E determines within the braces E, just you need to write E dot value is equal to E dot value. So E determines I dot value, and I here the digit is there. So this can be represented as 10 into I dot value plus lexical value. Okay, so I dot value plus lexical value. So the digit they are taking as some number. Okay, so 10 into I dot value plus lexical value. So this is about the syntax directed translation schema. Okay, now let's see the implementation of syntax directed translation. So this is an implementation of syntax directed translation. Let's see how we are going to implement whatever the grammar that we are taking. So based on that, the grammar, adding the semantic rules for that grammar and implementing the syntax tree. Let's see. The syntax directed translation is implemented by constructing a parse tree. So the thing is, you need to construct a parse tree by using STD, by using syntax directed translation, SDT. Okay, SDT, sorry. So by using SDT, SDT is implemented by constructing a parse tree and performing the actions in a left to right. So that you have to perform the actions from left side to right side. Okay, so whatever the equation that you are having, A plus B star C is there. So you have to perform the actions from left to right. starting from left and ending with the right. So SDT is implementing by parts the input and a parts tree as a result. Okay, so let's see the implementation of SDT. So by seeing this example, you can understand what exactly, how the process, what exactly the SDT was. Okay, so here I have taken the productions, and for the actions for that productions means the semantic rules. So these are the actions, nothing but the semantic rules. And this is the grammar, it's nothing but the productions. So for each grammar, this is an action. Okay, so now let's take an example for this. I want to calculate 1 plus 2 into 3. You know the result, 2 into 3 is 6, 6 plus 1, 7. So for answer is a 7. Now let's represent the parts tree for this thing, the parts tree. So first is take E dot val. So E dot val, don't take the value first. First construct the tree. So E plus T. Okay, and this E is nothing but T. Okay, and this T again divided into this T is divided into, not divided, it's reduced to F, and this F is num. Okay, now coming to this T, E plus T. So that again this T is T star F. T star F. Okay, and here again this T is T determines F, and the F determines num. Okay, and this F determines num. So the numbers for this is here 1, 2, according to our 3. So 1 plus 2 into 3. Okay, so now calculate the SDT for this, means implement the SDT for this. So I'm following the top down approach, left to right. Okay, top down, left to right, left to right. So starts from here and left to right I had to go. So from top down, come here. So first num, the num, whenever there is a reduction, so the num is reduced to F. So F determines num means the num is reduced to F. Okay, so whenever there is whenever there is a reduction, that is F determines num, the number reduced to F. Okay, so we go to the production, we go to this production, that is the F determines num, we go to the production and carry out the action. Whatever the action that is carrying, that action has to be placed here. Don't be confused. Whenever there is a reduction, so I'm moving from top to top down approach. Okay, so I'm going up. While I'm going up, so this num is the reduction. F determines num. Okay, num reduced to F. Num reduced to F. So we go to the production. So this is a production. For this production, what is the action? That action has to be carried out here. So the action is F dot val is equal to num dot value. F dot val is equal to num dot value. What is the num dot value? 1. Okay, so now again go here. So this F is there is a reduction. F, T determines F, means here this F is reduced. This is a reduction. Okay, so T determines F. So go to that production and see what is the action for that production. T dot value is equal to F dot value. So T dot val is equal to, what is F dot value here? 1. Okay, now come here. Now again reduction, that is T, E determines T. So it's nothing but E determines T means what is the action? E dot value is equal to T dot value. So E dot value is equal, what is the T dot value here? 1. So you're not supposed to go up, because still you don't know these two are combined with this expression. So Again, come down. Now check here. So this num is reduced. Whenever there is a reduction, okay, we go to that production. F determines num. So the production for that action is f dot val is equal to num dot value. The num dot value here is 2. Go up. So here there is a reduction. So T determines F. The T determines F. What is the action for the T determine F? T dot value is equal to F dot val. So already F dot value is 2. So just place here and come down here. So this is a reduction. Okay. F determines num. So F dot value is equal to num dot value, the action, that is a 3. Okay. Now come here. While I come here, there is a T reduction like T determines T star F. So this production, go to that production, and what is the action for that production? T dot value is equal to T dot value is equal to T dot val plus into F dot val. What is the T dot val into F dot val? That is a 2 into 3. 2 into 3 is equal to 6. Now T dot value is 6 here. Now come to here. So E, there is a reduction here. This is the reduction state and this is the determined state. E determines E plus T. E plus T. So go to that production and see what is the action for that production. E dot val is equal to E dot val plus T dot val. What is the E dot val here? 1. And T dot value is here 6. 1 plus 6 is equal to 7. So this is how you have to implement the syntax direct translation. So just take the grammar and for that grammar write the actions, that semantic rules for the grammar. Just you need to place dot val. Okay. So and take that equation, whatever the expression that you are taking, that expression should be represented in the form of parse tree. Okay. So while you are going up, this will be the reduction. So this is the reduction for this and this is the reduction for this and this is the reduction for this, because E determines T, T determines F, F determines num. So like that. So there is a reduction. So whenever the reduction is there, you go to that production and for that production, what is the action you have to take and you have to write that action here. Thank you.